we're going to have a look at the second formula for standard deviation then. We're still going to do a table, but the table's going to be a lot simpler. So all we're going to look at in our table is what x is and what x squared is. So x is, again, just your numbers in your list, say 7, 10, 18, 23, 8, 11, 19. So they go down to your x. X squared, we just square them. Hmm, 361 for the last one. Okay, what we're going to do then is we're going to add up x, and we're going to add up x squared. And we get 96. Add up x squared. One, 5, 4, 8. Okay, standard deviation then. Standard deviation, the second formula, is the square root of the sum of x squared minus the sum of x all squared divided by n all over n minus 1. Okay, making sure we're happy with what everything is then. Square root sign just the same as normal. Sigma, again, just means sum of, means add them all up. X squared is each of the numbers squared. The sum of x squared means you add up x, or all your x's, all your numbers. Sorry about my handwriting here. Add up all your numbers and then square. I'll try writing that again. There we go, that's a bit better, that's a bit neater, you can actually read it now. So it's just to point out the difference between these two. So this is the sum of x squared. So that means you square all the x's and add them together. This is the sum of x squared. That means you add up all the x's. Got to do that bit first because it's in a bracket. Then you square your answer. N, and it's the same n that's mentioned twice. N is how many numbers you've got. It's your number of numbers. Okay. Now again, it looks like a horrible formula, but we have, by doing this table, worked out a lot of the parts of the formula already. So it's the square root of the sum of x squared. You add up all your x squareds, so that's this total here. So this part here goes in here. So it's 1548 minus the sum of x is this here, because we've added up all our x's, so that 96 is this part here. It's the bit inside the bracket. So we need to do 96 squared divided by n's how many numbers we've got. 1, 2, 3, 4, 5, 6, 7. 5 by 7. All over n minus 1. So 7 minus 1. If you've got a good scientific calculator, you can do this top line in one go on your calculator. Check it on your own calculator. If not, you'll need to work out what 96 squared divided by 7 is and then do a takeaway. That comes out at 231.4. All over 6. Calculator going again. We're doing the square root of 231.6 all over 6. And that is 6.2. Okay, if I go back to the question just now, we've been asked to calculate the mean and standard deviation. I've only calculated the standard deviation here. I need to make sure I fully answer the question. So I want to find the mean. For the mean, I add up all my x's, which gives me 96. I've already done that. And I divide by how many numbers I've got, which is 7. So 96 divided by 7. It's 13.7. Now, there are two formulas for standard deviation. And the reason there are two formulas for standard deviation is if we use this data, the first formula, when we calculate the mean and we get 13.7, it was 13.7 something, 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 something. Okay, so 13.7 is a rounded answer. We would then take that off from each of them and then add them up. So we're losing part of our answer every single time. So you can think of it as, if it's a nice number for your mean, if it's a nice whole number, use the first formula. If it's not, use the second formula. But it actually doesn't matter. Okay, at National 5 level, you'll not get penalised for using one formula or the other. You can, at this point, say, actually, do you know what? I don't want to learn the second formula. I'm not going to bother. Okay. If we had an actual final exam, I wouldn't encourage you to do that because there has been a couple of questions where you've had to use one formula and not the other. But because there's no final exam this year, we could probably get away with just learning one of the two formulas. Okay, I'll leave it up to you to decide which one you're going to use. I'm going to do a second example using this formula because it is a slightly trickier one to get used to. The reason that I do teach it as well, I know some teachers don't, is I have found that students are more accurate with this formula than they are the first one. Once they get the hang of it, they're more likely to get full marks using this formula than the other one. Okay. Third example then, we're going to calculate the mean and standard deviation. If we're having a look at this one, if you look at the layout of this one, this is an exam question. I think standard deviation has been in every National 5 and every Intermediate 2 paper since then they started. Okay. Harry often plays golf and scores some of his games are recorded below. For this sample, calculate the mean, the standard deviation. We'll start by finding the mean. I tend to find that if I don't find the mean at the beginning, I've got a habit of forgetting to do that. So I'm as well always just finding it at the beginning regardless of what formula I'm using. So 84 plus 78 plus 87 plus 80 plus 81. That's 410. It's 410 divided by 1,235, which is 82. Now it's a nice number, so you could use your other formula, and if you are planning on using your other formula, I suggest that you use the other formula just now and check that you get the same answer. Okay. You don't always need to do a table using this formula. We've worked out the sum of x. Sum of x is 410. I can also work out the sum of x squared just by typing it into my calculator. I can just do 84 squared plus 78 squared plus 87 squared. So those of you who don't like loads of working. Plus 80 squared plus 81 squared. 33670. If you make a mistake on your calculator, you'd made that same mistake in your table, you lose 1 mark either way. Your table, or this way, you get a mark for your sum of x, you get a mark for your sum of x squared, you get a mark for subbing it in, and you get a mark for your final answer for standard deviation. Okay, formula then. Standard deviation is the square root of the sum of x squared minus the sum of x all squared all over n minus 1. Put some numbers into this then. That's the square root. Sum of x squared is 33,670 minus sum of x is 410. Doing 410 squared divided by n, which is 5, all divided by 5 minus 1. Which is the square root of minus 410 squared divided by 5, which is 50. Done my square root sign far too big then, let's try that again. So that's going to be the square root of 50 divided by 4. Now if you'd used the other formula at this point, you'd have got 50 for your total part of your column that you would then put into your formula. At this part, it should be the same. So it's the square root of 50 over 4. Which is 3.5. Standard deviation, remember, is telling us how spread out our numbers are. So if you have a look at these numbers, they go from 78 to 87. So they're not that widely spread, so you would expect a small number. Common mistake with standard deviation is forgetting to square root it at the end. So if you're getting a huge number, it could well be that you've forgotten to square root it. Okay, let's have a look at part B. Now what we need for part B is the answers for the original numbers for part A, which we can't see here. I'm just going to write them up here. $84, $78, $87, $80, $81. Yeah. Okay. So his partner for these games is Tony. His scores are listed below. Write down the mean and standard deviation of Tony's scores. Okay. It's a write down, it's not a calculate. So we're not asked to work out the mean and standard deviation for these. This was a 1 mark question, or might have been a 2 mark question, one for each one. But it's not asking you to recalculate. It's asking you to see what you understand from the words mean and standard deviation and see if you can write down your answers. If we compare the numbers then, if we compare these scores to these scores, what's happened each time? Each time they have gone up by 20. If each time these have gone up by 20, then the mean will have gone up by 20. So the mean for part A was 82. So your mean is going to be 20 onto that. So your mean would be 102. Standard deviation. Standard deviation is a measure of spread. It's a measure of how spread out your values are. Each one of these values has had 20 added to it, so they're no more spread out. So your standard deviation is going to be exactly the same.